My name is Winnie NYONJE. I come from Kenya. I'm a student at Kenyatta University of Agriculture and Technology. I'm studying PhD in Food Science and Nutrition. So yesterday I presented part of my PhD work. Today I'm also going to present part of that same work, which is on vegetable amaranth. So yesterday I was talking about phenotyping and nutrients. Today I'm going to talk about cooking and nutrients. So the title of my presentation is Enhancing Nutritional Quality of Vegetable Amaranth Through Food Preparation Methods. Co-authors of this work are Mary Abukutsa, ray-yu-yang, Wan-Jen, Anselimo Makoha, and Willis Owino. So as an introduction, amaranth is one of the most commonly consumed of the African indigenous vegetables, and its consumption has been on the rise over the years. So as it is consumed, there are different preferences varying by consumers, and various consumers prefer different varieties, and also various consumers use different methods of cooking. Now, there's, however, some general steps that are followed during preparation of amaranth for cooking, and these include plucking of the edible parts, and the edible parts here include the leaves and the tender stems in some cases. So the second step, which is also general, is washing. There's also chopping. Chopping is optional. There are people who don't chop. And then there's boiling, which is also optional. Some people don't boil. And boiling time also differ with people. The last step, which is also common, is stir frying in oil and tomatoes. That is a common step in East Africa, just frying the amaranth in tomatoes and onions, and other additives can also be added. So with the increase in consumption that has been reported over the years, there's still a problem of malnutrition, especially iron deficiency anemia, which affects mostly women in childbearing age and also children. So why is the problem of malnutrition, iron deficiency anemia still existing while people are consuming more of these vegetables? Some of the factors that can answer this are the varied cooking methods. The cooking methods can either destroy or improve or enhance the nutrients that are found in these vegetables. There are also anti-nutrients. For example, oxalate is quite high in amaranth, and oxalate bind minerals in the body, so the body will not be able to get the minerals that is reported from the lab. There's also the non-heme nature. There are two types of iron. There is the heme nature, the heme iron, which is mostly found in meat products. And then the one that is found in vegetables is non-heme iron. It has low bioavailability. So these are the factors that may be preventing the body from getting maximum nutrients from the amaranth. So the objective of this study is to enhance nutritional quality of vegetable amaranth using food preparation methods. And here we are focusing on iron bioavailability enhancement. So in this study, we chose three recipes that are commonly practiced. And then I made these recipes in the lab under controlled conditions and analyzed the nutrients in these recipes and also the iron bioavailability of these recipes. After that, I chose one recipe for food for improvement of the iron bioavailability, and this improvement was done through several food methods. After improving that, I compared a meal of amaranth using ugali in combination with an improved recipe as well as a traditional recipe. Traditional recipe, I mean the recipes that are listed here. I had recipe 1, 2, and 3. The first recipe involved boiling and frying without chopping, just taking the leaves, washing, of course, and then boiling without frying, recipe 2, chopping, boiling and frying, and then recipe 3, chopping and frying without boiling. So the boiling time and the boiling water were all controlled, and they were same for all the recipes that involved boiling. And recipe 3 was not boiled. The general ingredients that I used for frying was onions, tomatoes, and oil, which were also measured, and they were same for all the recipes. So the nutritional analysis was done using standard laboratory protocols. And this iron bioavailability, because that is the major focus of this study, iron bioavailability was done using in vitro simulated gastric intestinal digestion with dialysis tubing, where we use enzymes to simulate what happens from your mouth to the stomach, and then harvest the last amount of iron that we get. So the results that I'm showing here are results for nutrient retentions of the 3 recipes. I have also presented there the nutrients in raw amaranth, and then the nutrients in mixed ingredients without cooking. So just the ingredients that were used mixed together in raw form, and then recipe 1, recipe 2, and recipe 3, as I had described. So those are results for oxalates and for vitamin C. And the comparison that I'm making here is a comparison between the 3 recipes and the mixed ingredients without cooking. The amaranth raw is just for the standard. So if you check for oxalate, there was significant reduction compared to the raw ingredients. In vitamin C, there was also significant reduction. However, for vitamin C, the 3 recipes were not significantly different. These are carotenoids. These are results for carotenoids. And those are 4 types of carotenoids that were detected in the samples. So there is this carotenoid called violaxanthin. It was not detected in the 2 recipes that involved boiling, the ones that are 00, while the one that did not involve boiling, there was violaxanthin. The other 3 carotenoids were actually enhanced compared to the raw ingredients. As you can see, they are higher. Lutein, the amounts are higher in the recipes than in the mixed ingredients without cooking. So these results are in dry weight basis. That is why they are quite high. The alpha carotenes are also enhanced, as well as beta carotene. And if you check, there was no significant difference among the recipes for all the other 3 that were retained. So this is still nutrient retention. So there I have minerals, and I have calcium, iron, and zinc. Calcium was a bit enhanced slightly compared to the raw ingredients. However, there was no significant difference among the 3 recipes. There was also no significant change in zinc and iron. So I went ahead and did iron bioavailability or bioaccessibility using the dialyzability method. And this I calculated by using the dialyzable iron, that is the last iron that is collected over the total iron presented there times 100. So the bioaccessibility of iron for raw amaranth was about 11%, and for the mixed ingredients, it increased a little bit, the percentage bioaccessibility, and that can be attributed to the other ingredients that were added, including the tomatoes. For the recipes, they were enhanced. So if you compare the raw amaranth and the recipes, it is about double the amount. Though between the recipes, there was no significant difference in the bioaccessible iron. So because there was no significant difference in the bioaccessible ion of the 3 recipes, I chose recipe 1 for enhancement. And the enhancement was done using 3 strategies. Strategy number 1 was to use vitamin C, and vitamin C is an enhancer. So for vitamin C, I used tomatoes as a source and also lemon juice as a source. The second strategy was improvement using high iron vegetable, where I used moringa leaves. Moringa leaves just as a model. You can use any other high iron vegetables. And then boiling to see if boiling can in any way enhance the iron bioavailability. So this is the first results showing how iron bioavailability was affected by the 2 vitamin C sources that I used here, the tomatoes and the lemon juice. So for the tomatoes, I was using recipe 1 now as the reference point. Amaranth raw is also presented, but recipe 1, there is the uncooked ingredients. Recipe 1 here is the reference point, which I was trying to see if it can be enhanced. So for the ones that had twice the amount of tomatoes of recipe 1, there was a slight increase in dialyzable iron, which was about 19%. However, this was not significantly different. Lemon juice, however, enhanced the dialyzable iron by a higher value of 66% compared to the traditional recipe, which is the recipe 1. Okay. So this is the data where I used high iron vegetable, and I used moringa. Any other vegetable can be used. This was just the model for high iron vegetable. So the principle here was to increase the amount of iron in the whole dish, and therefore the bioavailable iron will be increased. So I used moringa and amaranth in a combination of 1:1. So 50% moringa, 50% amaranth. So moringa increased the dialyzable iron. A combination of moringa plus amaranth had 25% higher dialyzable iron uh, than the amaranth only, the amaranth boiled only. So I was boiling them and comparing. So you can see moringa alone has high dialyzable iron. So when combined with amaranth, it improves the dialyzable iron of the amaranth. So the other treatment, which was strategy number 3, was using boiling. So boiling, I regulated the boiling time, and also discarded water in one and retained water in the other. So I had raw amaranth boiled for 5 minutes, then discarding water. Amaranth boiled for 5 minutes and then retaining the water. 15 minutes and then discarding water, and then 15 minutes and retaining the water. So the boiling time, as you can see, boiling time affected the dialyzable iron, where the one that was boiled for 15 minutes, even with the retained water, had higher dialyzable iron than the one that was boiled for 5 minutes. However, discarding the water removed some iron. That is why there is no significant difference between this and the other one. So discarding the water is not an option. However, discarding the water is also the one that is reported to be the most viable method to eliminate oxalates, which is a binder of iron. So I went ahead and tested. I now had one recipe, that is recipe 1 from the traditional recipes, and I had an improved recipe which now had the lemon juice in it. So I have traditional recipe only, recipe 1 from the first study and improved recipe, which is the recipe with some lemon juice with enhanced iron. And then I had ugali. I hope we all know ugali. It's called sima here. So I was trying to see if you eat amaranth with ugali, will the components of amaranth affect the bioavailability of iron in the ugali, since the flour that I used for this ugali was fortified. It's iron fortified. So I wanted to see if the oxalate in amaranth can affect the bioavailability of the iron in ugali, which it did not. This is now a meal combination. This is a combination of ugali plus recipe 1, which was not significantly different with the ugali and traditional recipe. And noting that I took half of this and half of ugali, it is not significantly different, so there was no change. Also recipe, the improved recipe with ugali, there was a slight increase, but there was no reduction. So I concluded there that components of amaranth do not affect dialyzability of iron in the other meal. So that is towards the end. I am concluding that the nutrient retentions in the 3 recipes that were chosen for this study were quite high. Notably, the minerals, the 3 minerals had high retentions of up to 85%. And also carotenoids were enhanced by up to 45%. Enhancement of carotenoids could be due to the fact that they exist in protein complexes in the plant, and therefore during cooking, the complexes are detached. And also the oil that was used in cooking, oil is known to be an enhancer of carotenoids. So addition of vitamin C, which I did using lemon juice and tomatoes, using of iron-rich vegetables and boiling significantly enhanced the bioaccessibility of iron in the amaranth dishes. So, and lastly, amaranth components do not affect bioavailability of other foods in the meal. Okay, so once again, I want to acknowledge BMZ for funding the project through Amazing Amaranth Project, which is undertaken by World Vegetable Center and JQuat. So this work was done at the World Vegetable Center in Taiwan at the Nutrition Unit. I would also like to thank the organizers of this conference for sponsoring my being here. Thank you very much for listening.
Awesome. Is there anyone with a question from the audience? Anyone with a question? Yes. 2 quick questions.
Okay, thank you. First of all, I would like to say it's a good work. And I think if you also go further and do the sensory evaluation, like testing, I wonder if you did a blind test to see if it is also, the recipe that was more desirable could be eaten by other people rather than just a lab work.
Okay.
Yeah.
Thank you. The other part of the study that I have not mentioned because I have not presented here is that I am doing a survey on the existing consumption practices. And so I will take the principles from the survey, from the feedback from the farmers, as well as principles from this work, and then make some recipes and take those recipes for sensory evaluation.
All right. Last question.
Okay. First of all, I would like to thank you for your nice presentation, but also I had like 2 questions. Question number 1, we know that overcooking can affect the nutrient retention and bioavailability. So my question is there any specific time commonly for cooking vegetable to ensure that we are retaining nutrients and the bioavailability?
All right. Okay.
And the question number 2, you have told us that the cooking method can affect the nutrient retention and the bioavailability. So I would like to know at least which cooking method can enhance nutrient retention and the bioavailability, and which cooking method can retard or can lead to decrease in nutrient retention and bioavailability. Thank you.
Right, over to you. You can do it
Okay.
in 2 minutes.
So both of your questions are talking about the cooking time and bioavailability with nutrient retention. So over the years, the very traditional cooking methods involved very prolonged boiling and even fermentation. And as we know, most of the components that we target from vegetables, the vitamins and some bioactive compounds are usually affected by heat. So if you boil them for too much, you will lose most vitamins. You will be left by some minerals and a lot of fiber. So it usually kind of depends on what you're targeting. For bioavailability, from my study, bioavailability was enhanced by a little prolonged boiling. So if you want to target ions from these vegetables, you can boil, but do not overboil in order to retain some nutrients. I did not do very many time points to determine which exactly is the best time point for boiling or for cooking.